Engineers are proposing the most outrageous sea crossing in history. 5 times longer than the Hong Kong Zhuhai race,
standing directly in the path of monster super-typhoons. It requires building deep-water caisson foundations at high-speed maglev trains traveling at 400 kilometers per hour. Submerged concrete caissons the size of skyscrapers. World record heavy crane vessels maneuver 20,000-ton steel
5 times longer than the Hong Kong Zhuhai.
Integrated offshore wind turbines and solar pavement panels. Giant dredger fleets construct artificial islands mid-ocean, where international shipping channels cross. The high
over 1 million tons of high-strength anti-corrosion.
Soaring 70 meters above sea level.
Smart solar pavement feeds electricity directly into dynamic robotic inspection swarms crawl along main cables continuously.
Priced at $120 billion, it is the most.
Geotechnical fleets drill 150 meters into the sea bowl. Hydraulic seismic dampers and tuned mass dampers inside. The bridge secures Hainan's transformation. Graphene-reinforced self-healing concrete guarantees a 3D printed modular concrete caissons are permanents. Global civil engineers consider this project the ultimate.
Here is the complete engineering roadmap to building a
Phase 1, deep-sea bathymetric mapping and seabed foundation engineering. Survey fleets scan the South China Sea floor. Ships. Clusters of 3-meter-wide steel piles are driven 100.
Offshore pile drivers hammer giant steel casing turbines. Heavily reinforced concrete pile caps.
Hollow concrete caissons fill with water ballast. Settlers. Rock dumping ships pour thousands of tons of basalt armor.
Automated slipform casting systems build
implements. Graphene-coated steel rebar cages provide ultras. Rock dumping ships pour thousands of tons of basalt armor. Curved concrete wave deflector collars break ocean swells.
Self-climbing hydraulic formwork operates continuously.
Liquid-tuned mass dampers at the pylon summits neutralize.
Anchor chambers inside the concrete pylon. Dozens of mega pylons rise across the sea, ready for deck truss installation. Cable stay gantries hoist steel deck sections into place. Automated welding robots join steel box girders mid-air. Long-span cable-stayed sections span deep navigations. Side deck fairings and central gap vents suppress.
Hydraulic tension jacks adjust cable stay forces. Kilometers after kilometers, steel deck sections connect. Specialized high-durability epoxy asphalt paving protects. Giant modular expansion joints allow the bridge deck to expand and contract. Transparent porous wind barriers reduce deck wind speeds by 50.
Oil-separating deck drainage systems collect and fill. Double-deck truss spans house an 8-lane highway on the upper level and a 4-track.
Double-deck steel trusses distribute heavy freight train loads evenly across. As the bridge reaches busy shipping lanes,
artificial islands serve as transition portals where the highway dives into submergers. Massive granite seawalls surround artificial island board. Undersea tunnels bored from artificial islands allow open sea lanes above.
Phase 2 complete. Now explore the submerged tunnel sections.
Phase 3, submerged floating tunnels and deep water immersion engineering. The bridge secures Hainan's transformation. High-tension vertical steel tethers anchor floating concrete tubes. Precast 50,000-ton concrete tunnel elements are immersion barges lower concrete tunnel elements into deep water with laser.
Heavy Gina rubber gaskets compress between tunnel sections.
Subsea hydraulic jacks pull tunnel elements together with. Once locked, water is pumped out from between bulkheads. Elliptical tube profiles reduce drag forces from deep surface. Pontoons equipped with warning beacons support vertical cables in shallow. Hollow concrete caissons fill with water ballast.
Pressurized fireproof escape tunnels running alongside it.
Automated high-pressure water mist systems. High-tension vertical steel tethers anchor floating concrete tube.
This hybrid bridge tunnel configuration Robotic maintenance vehicles scan inner concrete lining.
Industrial drainage pumps remove seepage water continuously.
Steel concrete steel sandwich wall construction gives
Artificial islands generate their own power using solar roofs. The electrical substations on artificial islands step down high-voltage. Container ships pass safely overhead with 30 meters of clear water.
acoustic damping panels line interior walls reduced.
Bullet trains enter submerged tunnel sections at 300.
Integrated bridge and tunnel engineering solves the open ocean crossing challenge seamlessly.
Sensors track tilt, water pressure, and concrete strains.
Control operators monitor 1,000 HD cameras. Leaving the artificial island, traffic climbs back onto elevated.
Overhead catenary wires deliver automated multi-lane free-flow toll gantries scan vehicle license plates. An unbroken engineering ribbon bridging the gap.
The rail link connects directly into Hainan's high-speed ring railway. Phase 3 complete. Now examine the smart energy grid. Phase 4, green energy integration. Pylon photovoltaic road panels along emergency lanes generate megawatts. Grid-scale lithium battery banks on artificial islands store excess.
High-voltage substations convert renewable power. Inductive charging coils embedded in rail bed. High-speed track geometry cars scan rail alignment nightly. Magnetic crawling robots traverse interns.
Drone swarms wash ocean salt spray off stay cable sheaths. Smart LED lighting systems adjust brightness based on travel. Integrated 5G and satellite antennas along the deck. Central AI supercomputers process data from 50,000 sensors.
Artificial island emergency stations house fire crews.
Automated lane management barriers reroute traffic around accidents within seconds of delay.
Impressed current cathodic protection systems send
Maglev train technology enables whisper quiet 450.
Magnetic levitation stability ensures a completely smooth ride even when
mainland transport hubs merge high-speed rail, highway.
Shifting freight from fossil fuel ships to electric rail cuts.
Magnetic levitation stability ensures a completely smooth ride even when submerged pylon bases feature artificial reefs and kelp.
Maglev train technology enables whisper quiet 450.
Onboard radar and anemometer stations track wind gusts.
Dynamic overhead signage alerts drivers to weather conditions and automated deck sprayers apply non-corrosive de-icing fluid.
Integrated green energy and smart robotics make the 300 vibration sensors detect stay cable resonance, deploying ears.
Engineers inspect box girders remotely using high-resolution. Heavy freight rail decks support 30-ton axle loads. Self-monitoring smart technologies reduce maintenance costs. Phase 4 complete. Now examine the Phase 5, economic transformation. Automated smart customs gates process freight trucks. Annual trade across the sea crossing is projected to exceed
vast automated logistics parks on both shores.
Global tech firms and financial institutes. Travel time between Hainan and Gwangju drops from 12 hours. Over 50,000 vehicles cross the sea daily.
Artificial island service hubs develop into.
Travel time between Hainan and Gwangju drops from 12. Maritime shipping channels remain fully open, preserving international navigation. Automated smart customs gates process freight trucks, eliminating hazardous ocean ferry crossings drastically.
Engineers and urban planners worldwide study the 300.
Observation centers showcase the cutting.
The bridge serves as a critical node in a larger vision. Maintenance fleets utilize solar electric vessels to service submerged fountains. Materials test data confirms the bridge structure will withstand. Economic projections indicate full capital cost recovery within 15 years. Simultaneous highway and rail transit demonstrates the.
Passengers disembark at Hainan, complete a 300-kilometer monument to human willpower.
From deep-sea friction piles to self-healing nano-concrete, proof that no ocean barrier is too wide, no deep-water trench.
A $120 billion
Across the coast, these massive engineering marvels